Welcome, and thank you for listening to our presentation. My name is Vincent Heron from CFD Research Corporation, and our Navy topic is computational analysis of missile flight through rain. This is a new and very exciting capability and can be used to optimize missile cone and dome configurations to better withstand adverse weather conditions, therefore effectively extending the flight envelope. We would be very interested in meeting people who are responsible for missile designs or redesigns, whether it's government or primes, so please contact us if you're interested in the technology. A few words about the company. We were founded in 1987, we have 165 employees, and we develop cutting-edge technologies and provide services to government and businesses. On the software side, we develop and apply modeling and simulation technologies, while on the hardware side, we are involved in design, fabrication, and test and evaluation in aerospace, biomedical, and materials areas. We have transitioned numerous technologies into the marketplace, and we have had 3 corporate spin-offs, with 2 more in progress. We have 66 patents, and 34 patents have been out-licensed with royalty provisions. Due to the success, our DoD commercialization achievement score is 90%. This means that we belong to the top 10% in the country. We are located in Huntsville, Alabama, close to the U.S. Army and Aviation Missile Command, MDA, and NASA Marshall Space Flight Center. An often overlooked issue is the ability of a missile to fly through rain, although there are definite requirements to do so. The picture on the right shows the impact of a raindrop on the missile forebody. A forebody or a seeker dome may even get damaged by rain impact. This all depends on the flight regime, local flow field characteristics, and forebody dome shape. The images were taken from experiments designed to get more insight into the problem. But main unknown remains the degree of raindrop distortion caused by the flow field around the missile in transonic or hypersonic flight. This is why we have developed our simulation capability, and the primary transition target is PMA 259 air-to-air missiles. Operational need and improvements. There are requirements to fly a missile through rain, but there exists the potential for missile, cone, and dome to get damaged during such rain. For now, no analysis capability exists, and there is no easy way to predict the impact of raindrops on the forebody and dome during various flight regimes. We have developed our software tool to optimize existing and new missile, cone, and dome configurations to withstand adverse weather conditions. Primary transition target is PMA 259, air-to-air missiles, but the software is equally applicable to other missile programs of US Navy, Army, MDA, and primes. To reach our goals, we have created a new state-of-the-art software tool. It is a first principles-based, high-fidelity computational fluid dynamics tool to predict raindrop distortion and demise in the flow field around the missile in supersonic flight, to understand both the impact event and the associated material damage mechanisms. Along with that, we have performed experiments that resemble missile flying through rain. We will use those experiments to validate our software tool. In addition, we plan to demonstrate our software tool on generic missile cones and domes at typical altitudes and flight speeds. The image at the bottom shows a typical raindrop distortion in the missile flow field as a function of time. We are roughly halfway into a 2-year Phase 2 contract. We have developed the computational capability, and we have performed experiments for relevant flight speeds, elevations, and missile configurations. We are in the process of using the experimental data to validate the computational capability and to perform parametric analysis of relevant Navy missile cone and dome configurations. At the end of the Phase 2 project, we plan to be at a TRL 5. After Phase 2 project, a Phase 2 option is planned with detailed analysis and demonstration of capability to successfully assess probability of failure as a function of raindrop size, velocity, distortion, and angle of incidence. In the end, we'll finish with a TRL of 5 and capability ready to be used and tested by national labs, PMAs, PEOs, and primes towards higher TRL levels. There are numerous advantages and benefits of the chosen approach. We believe that the complex flow of physics requires a first principle-based modeling approach. Second, such a capability only adds value if it has been extensively validated with experimental data. And last but not least, we will end up with improved weather-tolerant missile designs and improved operational capability and flight envelopes. This is of great importance to the warfighter and to the United States. We are halfway into the base Phase 2 program, which ends February 2022. We are ready to start talking to potential transition targets now. Primary transition target is PMA 259, air-to-air missiles. As I mentioned before, we would be very interested in talking to representatives from PMA 259, as well as other DoD missile agencies, as well as the missile primes. We are looking for agency and industry partners to demonstrate the technology, perform analysis projects of specific configurations, and customize the software to their needs. We envision the partnership to entail a software product as well as project-based services to support the software product. The software will be available towards the end of the Phase 2 project. Software is ITAR, and we plan to make the software available to all missile agencies and primes that are interested. We want to have as broad of a user base as possible. This in turn will create a relatively large user base, enabling project-based services to be performed by CFD Research. Services could be as simple as installation and training on the software, and if the user does not want to run the simulation tool by themselves, we can perform simulations on specific end-user missile configurations or perform parametric simulations to optimize designs. Customization of the software to end-user needs is another possibility for additional projects. Thank you for listening, and we are available at the virtual booth during the conference. Please ask for a chat. We would love to talk to you. Or if it is after the conference, please give me a call directly. Thank you very much. Bye-bye.